Hello everyone, welcome to the next session of SAP online training tutorials. So in this session, I'm going to explain about what is persistency layer in HANA and what is the use of it and why do we need it in HANA. And then we'll also look into how to do a backup and recovery process in HANA system. So now let's get into persistency layer. So in the last session, I explained about SAP HANA architecture where we saw persistency layer in index server. So why do we need a persistency layer? Do we really need to persist the data in HANA? Then the answer is going to be yes, because SAP HANA is in-memory database. So when we say in-memory database, everything is stored in memory. So when we are saying that your entire organization data is residing in memory, now what happens if the power goes off, or what happens if you have to restart the system? Because your RAM is nothing but volatile storage, which means it's a temporary storage. Until you have the power to the system, it stores the content. Once the power goes off, everything will be cleared from memory. So when we are talking about organization data, it will be in gigs or terabytes, like 500 gigs or 1 terabyte, 2 terabyte. Now I cannot go to the customer and say, okay, if power goes off, you have to reload entire data from your source. So it's going to be not possible thing for the customer. So in that case, the best way is whatever the data you have in your memory, have a replica of that data set in a persistence format. So that is where we have persistence layer in HANA. So this persistence layer will be in index server. So we have index server which stores all the data in HANA database, and the data will be in memory. So the same index server will have a persistence layer which consists of both data volume and log volume. So if we look at our picture, so the data that is residing in memory will be moved to or will be copied to our persistency layer in two formats. One is your data volumes and other one is log volumes. So data volumes, so we are going to have data volume as well as log volumes. So data volumes consists all the changes, all the committed changes, and this will have the changes that made from last save point. So now what is save point? Save point is nothing but the process of copying data from memory to persistence layer. So the process that exists while copying data from your memory to a persistence layer, which is data volumes and log volumes, is nothing but a save point. So this save point will be performed automatically in your system. So we no need to do anything manually, but what we can do is you can set the time interval for a save point to run in the system, and this is going to be asynchronous mode. It will be running in parallel in the system. So we can set the time frame for save point and the best time frame required for save point is every 5 minutes. So every 5 minutes you are going to have copy of your data residing in memory in persistence storage. So this persistent storage can be a traditional disk, or it can be SSDs, or it can be flash drives. So most of the times you get either SSDs or flash drives, so that the data copying will be a lot faster when it compares to traditional disks. So now how this save point will be performed in the system. So this save point has three major steps. Okay, so save point has three major steps. So when we are talking about storing data in memory, all your memory will be divided into different pages. So the data that will be residing in your memory will be stored as pages with internal indexes and pointers. So when a save point starts, as a first step, what it will do is it will identify how many number of pages has been changed from last save point. So it will identify how many number of pages has been changed in the phase 1, and it will coordinate the triggers. When the save point is running, it will coordinate all those triggers. We don't see all this in the front end, but this is how it operates at the back end level. Now that will be a part of phase 1. In the next phase, it's it will start the write operations. So it is going to have a control on the write operations that will be performed in the next phase. In the phase 2, whatever the pages that have identified as changed pages in the phase 1, system will not allow any write operations to those pages, which means those pages are locked to copy to your persistence layer. And that is where once that lock has been set, all those pages will be written to temporary buffer. Okay, then system will also identify what are the open transactions. I mean, whether it can be inserting into a table, or it can be updating the records, whatever it is, it will identify all the open transactions, and all these open transactions will be moved to your log backup, uncommitted transactions. And then as well as it will also identify row store information for uncommitted changes made during phase 1. So between these two, like between your phase 1 and phase 2, it will identify what are the changes, uncommitted changes that has happened, and then it will also set the log volume position. Once all these logs and then writing those modified pages to buffer happens, the system will release the lock so that it will allow again write operations. Why? Because all the changed pages has already written to a temporary buffer. So we know what has to be written to our data volumes. So system will release the lock that is applied on those modified pages, so that system can now allow the write operations. So in the third phase, all those pages, changed pages, will be written to data volumes, and all the uncommitted transactions will be written to your log volume. Once the changes has been written to your data volume, whatever the temporary buffer that has been used in phase 2 to write those changed pages, that will be cleared off. And the next one is our log volume. Log volume is always overwritten. So once, let's say you have the last successful save point was happened at 10 a.m. in the morning. Now at 10 a.m. the data volume as well as log volume has been filled up. Now when you run next save point, let's say at 10:15, so your data volume will get filled up and your log volume will be overwritten. Why? Because we know that now whatever the changes that has happened till 10 a.m. and between 10 to 15 a.m. we have got everything into data volume. So now we don't need the log backup or the changes that has happened before 10 a.m. because we already have those changes. So that's the reason now your log volume stores the uncommitted transactions that were happened between 10 and 10:15. So all the uncommitted transactions that were happened before 10 a.m. were all cleared off. So now this will have the changes, uncommitted changes that has happened between 10 and 10:15 a.m., which is going to be the latest one. So this is how save point happens in the system. Now let's say how you can restart the system. Like when you let's say you have got some power failure or system shutdown. When you restart the system, how the data will be again copied back to your memory from persistence storage. So it will check both your data volume as well as log volume, because data volume consists of all the committed transactions and the log volume consists of uncommitted transactions. So you need both. So it will load first your data volume into memory and then your log volume into memory. So this is what our next slide consists of. So when we reboot the system or when power failure happens, if you want to restart the system, you have got save point data till here, and then between these two you have got your logs written to persistence storage. So you have got all the uncommitted logs written to your log volume. So when you copy those two into your memory again, you have got the latest data available in your memory again. And when you restart the system, it actually restarts with lazy mode, so that there won't be so much burden on the system while copying data from your disk to memory. Why? Because with the lazy restart, what happens is it will first load all the major tables or all the recently accessed tables data first into memory. Or even while creating table, we can set the preload flag, which means we are informing system saying that this is one of the critical table. So when we are restarting the system, make sure you load data to this table first. So we can set the preload flag while creating a table in HANA system. So these about persistency layer. Why do we need persistency layer, and how the data will be reloaded to memory when we restart the system or when we reboot the system. Now let's think about scenario where you have got system crash. So when we say system crash, your system is gone, which means even your persistence layer is gone, because your persistence layer is part of your system. So it's a component in your index server, which means it's part of your system. So when your system is crashed, even though you have data in persistence layer, it's of no use now. So you need to go back to your source again to load the data. This is again going to be unacceptable scenario for the customer. So how can we overcome this? So this can be overcome with external data backup. So what we can do is, on a regular interval basis, we can take a backup into external system, backup into external disk with the help of HANA Studio. So from HANA Studio, we can take the external backup from a persistence layer. So now you've got data in memory. So whenever we load data into HANA, this will be loaded into your memory. Okay. So from memory, we are replicating it into persistency layer. So persistency, replicating into persistency layer as data volumes and log volumes. Okay. So these, even though this is a persistence part, both data volumes and log volumes, but this is still a component in our system. So when we get a power failure, you can recover the system with the help of data volumes and log volumes. But when you get a system crash where your both data volumes and log volumes is also lost, you don't have an option. You have to go back to your source to load the data again into HANA. So to avoid that, we need to take external backups. So that external backup can be taken from your persistency layer. So we can take external backup from persistency layer. So what we have in persistency layer, we have data volume as well as log volume. Along with these two, we also need another information, because when a power failure happens, you are going to load just data. Why? Because when you restart the system, you have all the system configuration information already available here. But when system crashes, you need a backup of your system configuration files as well. So when we are taking external backups along with data volumes and log volumes from persistence layer, you need to take configuration files backup as well. So along with data volumes and log volumes, we need configuration files backup as well, so that when a system crash happens, when you restart the system, you can load your configuration files and then data volumes, then log volumes, so that you will get your system into latest state when it was crashed. So this is what it explains, like you need data volumes backup as well as log volumes backup and configuration files. So how can we take the backup? Let's get into our system. Most of these activities as a modeler, we won't be doing anything. So it's all administrative DBA tasks to take the backup and recovery. So to take a backup, you have an option here, backup and recovery, and then backup the system or open backup console. I won't be having an authorization. You need to have this privilege, then only you can do the backup of the system. Okay, so when you go to that console, from here backup and recovery, you can choose what is your target disk to which you want to take the backup, and then when you start it, the system will be performing a backup in the backend and everything will be loaded into your external disk. So when a system crash happens, you can reload from there itself directly using a recovery option here. So same way, you can go to backup and recovery, recover the system, and then you can select the location of your external backup. Then system will start performing recovery from that particular backup. So we have different recovery options. Like when we do the system recovery, the first thing we'll be doing is load the data volumes along with your log volumes and then configuration files. So this is going to be the recovery process whenever a system crash happens. If it is just a power failure, you can recover your system from persistence layer itself. So to summarize what we have discussed in this lesson, we have seen why do we need persistence layer in HANA database and how the data will be copied from a memory to persistence layer with the help of saving point. And then we have also seen why do we need external data backup for HANA and how to take external backup as well as how to recover the system with the help of external backup. Thank you for watching. Have a good day and happy learning.